Wild beast attack. Yeah, I love you too. Hi, this is Chris, the guitar amp tech from Sydney, Australia, being attacked by a wild beast. As I was saying before I was so rudely attacked, the Fender Hot Rod Deluxe is probably one of the most popular amps of the modern era, and for good reason. They're well priced, they sound great when they're set up properly, and we're going to do a bit of that today, and also sort out a couple of other little performance issues that it has at the moment, and the customer wants to make it a bit more reliable. There's some well-known problems with the Hot Rod Deluxe, or that whole Hot Rod series, as you probably know. If that sounds of interest to you, go grab yourself a coffee. Sounds like a good idea. Pull up a chair and let's get started. Oh, good, you're back? Good. Got your coffee? Good. That doesn't look like coffee to me. Anyway, who am I to judge? Okay, I haven't heard this yet, so... No crackle. Bit of a hum. Thought I was going to say they're my first set of pickups that Lindy Fralin made for me, but no, he made me a PAF for my then 335. But I had a 61 Strat, a real one, which I was too chicken to take 20 gigs. So I asked Lindy if he could make me a set of pickups that would sound like the Strat, the 61 Strat, which I then had a Daphne Blue custom shop. And we took some measurements, he made them up. It sounds so close to the 61 Strat, probably better actually. Anyway, I digress. Can't hear any crackles. That's good. Well, I gotta say, I'm pleasantly surprised. These are the two resistors that form the low voltage part of the circuit for controlling your ICs. That in combination with a couple of Zener diodes. They work pretty hard, these things. On one side of the resistor there's about 45, 50 volts. On the other side there's 16 volts as dictated by the Zeners. So it's a fair voltage drop that's across there. Yeah, what's that, roughly 30 volts. And yeah, so these fellas get pretty hot. Not uncommon at all to see the board underneath them having gone brown from just too much heat, and that causes solder issues, which can sort of melt even from the heat of these things and create a dry joint under there, and all of a sudden you have issues with being able to switch channels and go into drive mode, etc., etc. Two stages of rectification of this problem. But stage one is to get some new resistors because I need longer leads. I elevate them above the circuit board by a little smidge. I use these nylon standoffs, and that's stage one, just to sort of stop that direct heat contact with the PCB. And when I've done a couple that have been really bad, I have these other heat sinked resistors, which I will adhere to the back with heat sink compound. And well, then you're never going to have a problem, but it's just a bit more of a pain in the butt. There's the stock standard one I'd replace it with. And when it gets really nasty and I think nothing's going to stop that heat, I'll mount these off the circuit board, heat sink them to the chassis. The chassis will act as a heat sink as well as the aluminium casing here. So you'll never have a problem again, but it's just a bit more of a pain in the ass to do, and you know, pain in the ass for me means cost for the owner, so we avoid that. The question is whether I need to do anything because it's showing no sign of it. So I'll just think of that. Yeah, it looks like it's had a relatively easy life. These look like the original tubes. They haven't discoloured and gone sort of this grey colour, so I suspect they're still pretty healthy. We'll check these for microphony. I can't remember if I asked the customer how he wants his amp set up in terms of at what volume he wants a little bit of grit happening. So we can do that by setting the bias. And the other really easy way that you can do is just replace the ubiquitous 12AX7 in that V1 position with either a 5751 or a 12AY7, which is my preference. Also, these things leak pretty often. Can't see any sign of leakage, you know, of the dielectric leaking out. However, I will still check their ESR and make a decision based on that. I think the short answer is if I have to take that PCB out, I might as well change them, because if they haven't failed today, they'll be failing tomorrow. So it's a bit of a no-brainer on that one. The jacks, I think this was one of the issues. Yeah, I hate these PCB mounted jacks. You know, all it takes is one tug on the guitar lead and we've got a problem. Now I'm just going to give you a little tip of the day. Imagine that handle is not broken. I've ordered a new handle. In fact, I think it's here. Remind me to attach that, won't you? It's a new handle for it. Okay, tip of the day, especially for those amps that have got the plastic input jack. Don't just plug your guitar in like this, because when the bass player says, oh, how do you play the note A? And you walk over there to show him where the A is on his bass, you pull on that and you've just snapped this pathetically stupid plastic socket. So to avoid that happening, just give it one loop around the handle, please. And now when the bass player calls you over to say, where do you find the note A? That's really strong pressure I'm applying there. I don't want to wreck my lead. But that will no longer snap that plastic jack off. And the customer wants both of those replaced, so I'll do that. In which case, you know what? I think I will replace them. All right, I'm not sure if you can see my voltmeter there, but I just want to see if I've got any residual voltage on these caps. Okay, now we're going to check the ESR, equivalent series resistance. You can have a look at the Ampeg M12 video that I did recently, where I describe what a capacitor is and what equivalent series resistance is, ESR. A capacitor in its ideal form is just a capacitor that passes AC, blocks DC. But in the real world, it has a equivalent series resistance. Not desirable because the resistor acts just like a resistor. When you have a current passing through it, it will heat up. Heat is the enemy of capacitors, and you'll see on most capacitors a rating on it like 85 or 105 degrees Celsius. So heat's the bad enemy for caps, which makes you wonder why the hell did Fender do that with these poor little capacitors right near the major heat stresses of those two Zeners and there. Anyway, so, and there's also an equivalent series inductance, which in the leads, which is not really relevant to us at audio frequencies. So I've made myself up a handy little table here, where the first cap we'll look at is this 47 microfarad, 500 volt. F&Ts are averaging around 0.93 of an ohm of equivalent series resistance. This little table I found online says around about 2 ohms, so they're a little bit more liberal. Now with my ESR meter, I've set it to equivalent series capacitor, electrolytic, and ESR I've selected, and I've also selected the frequency, which the smaller ASR meters like the one I used to have, still have, just measured at one frequency. I think it was 1 kilohertz. So this is much more accurate in the real world, because these filter caps are all going to be measuring at 100 hertz in Australia, 120 in the US. Okay, so it should be about 0.93. It's nearly 4 times that F&T value, or if we just go for the generic, it's nearly double that. So that cap has to go. Let's try this 22 ohm. While it's settling down, we'll have a check on the table. 22 in the F&T world, 1.6. And everywhere else, 3. And this has got an ESR of 11. So we know that this cap is not long for the world. Even though there is no leak, visible leak of the dielectric material yet, we know there will be. 10 ohms as well. These 3 at least are going to go. Look, while I'm at it, I might as well change that fellow as well. So we're going to have to flip this board out. To do that, all of these have got to come off. Now, for some reason, Fender have used 2 different size nuts for their 6.5mm sockets. So to avoid getting them mixed up, just put them in 2 separate places. Like I'll have all of the general nuts in my little parts tray. I think it was from an old fridge. And I'll keep the unusual size nuts for the preamp in and out in another, in that little glass jar. I might just have a quick chat about desoldering techniques and tools. I've got a few different desolderers for Fender eyelet boards where you just got masses of solder to remove. I use this. It's got a nice big chamber in there. It's got lots of suction. You've got to clean it up every now and again, and I just use a bit of rubber grease to improve the seal. The only problem with this one is it's a 2-handed job. For smaller tasks, I really like this little thing. It's Engineer brand or something, but you can do it all one-handed. Obviously it doesn't have the capacity, the vacuum capacity, the other one, but on its plus side, it's got this nice little soft silicone tip, which creates a good seal around the item you want to desolder. And this is my desoldering tool, powered one. And on a PCB, this is pretty much what I'd use all the time. The others are just not great for a PCB, you end up applying too much heat, which is why I don't use solder wick anymore, because there's just so many better ways of doing it, and I just don't like keeping heat on the circuit board any longer than necessary. You can see here in the assembly process, see how they bend over those component leads? Well, that's the trap for young players who think, oh, I might see if I can pull that capacitor out in one piece. You can't. Because when you try and pull that capacitor out, those little barbs are going to hook onto the pads, and man, you're going to tear stuff for sure. I clip it on a straight bit. And then get that lead out of the way. So if you get your finger under there, it gets a bit hot sometimes. And if I'm wimping out, I might just Put a bit of masking tape over the fingers so to avoid getting burned. It usually helps just to give it a bit of fresh solder. And then poke that through. And another way of getting a nice clean desolder is to just apply a bit of flux with some fresh solder to it. I'm just using these pen type of fluxes. They work great, I gotta say. And there's just no mess compared to the previous paste that I used to use, because that used to leave just horrible goop on the board. Right, let's just pull these old caps off. Just get off as much as this is practical. Just blow off some of these. You know, I finished engineering at New South Wales Uni in 1981. I graduated. What's that, 42 years ago? Jesus. Anyway, my first job out of the university was working for the Royal Australian Navy as a part of a team that would maintain the training equipment. It was a high security building, several stories underground. I won't mention what it is. I had to sign a secrecy agreement, Official Secrets Act or something. And we used to maintain the computers, which were fairly basic back then, as you can imagine. And the plotting tables and radars and all that sort of stuff, a lot of which still had tubes in it, surprisingly, as well as some very sophisticated high-tech stuff. What was the point of that? Oh yeah, so one of my mentors there was this British guy, a guy called Terry Flood, bit of scholastic, and Terry was a stickler for doing things the right way, the British way. And he would be on my case, you know. He said, "Oh, one day you'll thank me for this." And I thought, I doubt it, Terry, but I do. You know, and before the days of, you know, wire ties, we would have to lace all the bundles of wiring together. And it was all about the quality of the work and how the work looked. And yeah, everything had to be straight, everything had to be perfectly oriented. Yeah, each capacitor had to be, yeah, no wonky legs. Oh, Terry would ever go at me about that one. And yeah, so here it is 42 years later, and probably Terry would no longer be with us. If he is, he's probably a real old fella now. So all I say is thank you, Terry, because it was all about pride of your work, and he gave me that pride. And I can look at my work and say, yeah, I'm happy with that. All right, one down, 4 to go. Just straighten that leg up a bit before Terry chastises me. That's pretty good. There's another little thing I do just to sort of keep everything looking nice. I use these dividers, and I measure the distance between the holes. And then get the capacitor spaced evenly between those two legs. I'm not sure if you can see that or not. And then just bend them over there, so it becomes my lead bending tool as well. And I know that that's going to go straight into a hole. And I checked them, all three of the 22 mics are the same. So I might as well just bend them all. Labels facing upwards. There we go, Mr. Flood. What do you reckon about that? Now, before we go and replace these plastic jacks, let's have a quick look and see how these Switchcraft jacks work. I mean, these last in quality amps for decades. These last for, you know, if we're lucky, warranty period. So you plug your lead in, the tip carries the signal, I've got this little red wire, out to your, from the guitar to your amplifier. The ground is going to be connected to that one there. But there's this other tricky little bit in here. I'm not sure if you can see what's happening here. You see that that leaf there, that contact, has now separated from the hot one. When I pull that out, it contacts it. And when we wire this up, currently it's not connected to anything, that's the middle one. But we're going to connect this middle one to ground. So what's going to happen is when we have the lead pulled out, your guitar lead pulled out, the tip is grounded by that little switching contact. Now the plastic ones have exactly the same sort of system, but not quite so easy to see. So we're just going to plug this in and we'll see, we can see here there's these two connectors here, these two solder points here. They'd be both ground, and one of these will be the tip. So here's our ground, and that should be there. Yes, 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 yes. Now this is our tip, so we now got to see which one of these two will. One will be the tip, one will be the sleeve. That earthing contact. There we go. That's the tip. That one won't conduct now because it's parted, and so the tip was on the left hand side there, so I suspect this will be the same again. Okay, so we're going to we'll connect to either one of these as the earth, and then we're going to connect the tip to the left hand one. And just to help me remember, I'm just going to put a little subtle blue dot there, and that's where we're going to put the tip. We don't need to do this connection here because we're going to do that on the jack itself. All right, I'll get my shielded cable and we'll pull these ones out. Trim a bit off there. And you got to make sure there's not any strand of the shield which will short out our signal to ground, so we don't want that. And that's fine enough to just strip with your thumbnail. Just want to tin both of these parts. So I'm using shielded cable. I mean, it's only a very short run. Very low signal level. And so now I've got to try and get that in there, and I might just give that a bit of a kink. Just give that a bit of a bend. Bit of solder. I don't know why Americans call it solder. I mean, it's clearly spelled with an L. All right, that looks all right. I don't think I've shorted anything there. And then you can go in here. And the tip. That looks good. I'll do the other one. You don't need to watch that. Just as boring as the first one. Well, it's the next morning, and I've been giving a thought about what to do about these large wattage voltage dropping resistors. There's no sign of heat stress on the board now, but man, I've seen so much of it, I think we'll do it. It's like the old, look mate, while I've got the front of your engine off, do you want to change the water pump? Well, it ain't broke, but one day it will, and it's going to save you a lot of money. So I think we'll do this. And I'm just going to do standoffs. So I'm going to use my little nylon standoffs, which, you know, will be enough to sort of keep them a bit more stable and just depending on the actual lead itself. And I might even pre-troll myself. I reckon someone's going to go, oh mate, nylon, that's not going to last. The temperature, I'm not sure. Let's try it. I haven't done this before. I'll put an old tip on. And you can see my temperature control over here. No, it's not 999 degrees, but I'll get there. So I just want to keep increasing this until I see what temperature it melts at. And then, yeah, we're going to go, well, is it likely that the resistors are going to get that hot? So this Goot soldering line is pretty fast. So already we're up to 160 degrees C. Oh, there it goes. What's that temperature? 362, and it's starting to melt at the bottom there. Okay, so we're going to say 360 degrees. I guess I've got to say, what's the likelihood of that resistor getting up to 360 degrees? I think not very likely at all. So it goes in the bin. I bought a few of those spacers, a couple, about 1,000. So that's enough to see the ideas. That's enough to do 500 hot rods. Should last about a month. So I've put the first one in, and it's better to have the board upside down, solder side up, so these little spacers don't fall out all the time, which is really annoying. But this is all right. Now I just got to make sure that I have the words the right way around. No, I didn't. Okay. Right. And the other thing is always bend the leads towards the track, because I've seen on a number of certainly more budget amps where they bend the lead over and it can actually short out. Like if I bent that over towards where that one is bent out, you could get a really unpleasant short. So bend them along their own tracks. A bit of this no mess flux. I'm not doing any SMD stuff. Just don't touch it. I know it's the way of the future, but those SMD boards which I have tried to repair, nearly every time the distributor or manufacturer says, mate, we just replaced the boards and recommend you do the same. Okay, that's nice. And now we'll just trim that up a bit. All right, well, that looks pretty good. Let's have a look and see what those resistors look like on the other side. Not sure if you can see that. That's pretty good. I will probably glue those together, but you've got to be careful with what sort of glue you use, you know. I can't use hot glue because it'll melt. I can't use Celastic because it'll probably burn. I might use a bit of either epoxy or contact adhesive, just to sort of stabilise them. When they're together, they ain't moving. When they're separate, they will move. And that's why I use the little standoffs. It just secures them a little bit more than just having them stabilised by the lead on themselves. But otherwise, man, I'm thinking we're pretty much done. So I used contact adhesive, and I'm going to use a wire tie to just hold the two resistors together while that glue sets up. Should they ever need to be changed in the future, they'll be changed as a pair anyway, so I think this will be the most secure method of joining them together and providing a good, strong support for each other. It's almost like life, isn't it? Okay. That'll do. Do me a favour and remind me to clip off that wire tie before I put this back together. All right, let's just have a look at the path of the signal here. Into here, into that little switching contact there. Then part of it will then go off to the reverb, and part of it will then go down here into our phase inverter. So this socket is critical to keep scrupulously clean. So whether you use this or not, give it a clean. How are you going to clean it? Well, you're probably not going to be able to clean it as well as if you pull it all apart. But at the very least, give it a bit of a squirt of some sort of cleaner. Definitely not WD-40, like a contact cleaner, and then get your jack and plug it in and out a few times. That'll help clean a couple of the contacts. Now that's the input jack that we took out, and you can clean those contacts by lifting that up with a guitar plug and clean in there. That's your main contact point. Now, because these ones are such complicated switches, now the other problem with these, with the way we've got this upward facing panel, we're going to get dust landing on these sockets, and some of it will fall in. So, you know, I know you don't have a compressor, but that's our foot switch. And this is the most critical one. This is that, the return jack, what they call power amp in. This is the one that we got to make sure has got a very good clean contact. Lots of amps have this problem with their send return jacks. I remember the early Mesa Boogies had routine problems of this cutting in and out, and it was these jacks there. All right, now I'm going to give these pots a bit of a squirt with deoxit, but you know, I don't want to keep bending this board back and forward because I've got to protect these ribbon cables. I decided not to change the Zener diodes. They seem to be in very good condition, no heat sign on the board, and these are the first things that we're going to see a problem with. There's also this little resistor here. I think it's 2 watt, R97. It's a drop-in resistor for the supply which controls the foot switch. Another thing that's worth checking is where this board is getting its earth from. So let's just do a test here. There's our ground coming in to the amplifier from the mains, and we know that the negative side of that capacitor is grounded. No contact. I know you can't see the meter, but you would hear a buzz like that. So no contact there. Now let me just get that end of the capacitor, and here's our earth lead that's connected to the PC board. So everything here is dependent on that lead. And that lead is just dependent on this tiny little screw hole. That's it. That's your earth for this entire board. So I'd suggest let's solder the lead to that to give it a good strong earth. Solder the lead to there, but then you can't flip this board out. So at the very least, because all that is currently depending on is the threaded part on the inside of there, because this has got some sort of anti-rust coating on it. So I'm going to now give that a clean with some sandpaper, give that a clean with some sandpaper, so that at least we're going to have a better quality earth. Okay, I've sanded off those. It's like a 1 minute job, so it's crazy not to do it. And also I just want to solder that earth wire to the lug, because in time that will build up some sort of oxidation. And I prefer solder for an electrical connection as opposed to crimping. There we go. Beautiful, mate. Another little catch, which has caught me many times, is this little LED that lives up here. I think it's the More Drive LED. It just needs to get a little bit of help to go into its hole, or else you end up pushing it inside the chassis and you've got to pull the bloody thing apart again to poke out your little LED. And he's going to do it to me again. Yes, good. Little switches, yes, they can move freely. They often catch as well. Well, we're not finished yet, but we're going to see if I haven't screwed anything up here. Okay, so I've got the new sockets in. Really tight fit. The much shallower clearance on the plastic pots than plastic jacks than the Switchcraft. Got them to fit in. I've got to go through my current limiter. When it's in limit, this bulb limiting will be activated. If all is well, then I'll put it to current, and that'll be, you know, full power, and I'll be able to read its current draw from my little analog dial there, which I think is very groovy. Now we'll see a little bit of a glow come on when we first power up. So when that power switch comes on, it's the transformer energizing. And then where's our standby switch? Oh, standby switch is here. So it's before the capacitors. So we expect to see another glow of the current limiter bulb when we turn that standby to play mode, because then we'll be charging up these filter caps. Here we go. Okay, that's promising. Nothing, if there was a dead short or something, that'd be glowing very brightly. Now I'll just play some music through it. A good way to not get any copyright strikes is to play your own music, because no one's heard of me. Okay, come on, play, play. Yes! I know exactly how old this song is, because my daughter is now 33, she just turned last week, and she was 12 when she sang some backing vocals on this for me. I wrote this song for my drummer at the time, who was going through a marriage breakup. Little did I know that within a few months I'd be singing this song about myself. It's called I'm Leaving You. Just want to get to the part where my daughter sings. Isn't she cute? Okay, well, we know the amp works. That's great. So the next thing I want to do is I'm going to just discharge these caps for safety reasons. Then I'm going to put my bias checker on this, and you can help me set this bias. Now, I don't suggest that you go around beating up your tubes, because it's not good for them. But let's see if you can hear this. Where's my little mic? It's around here somewhere. Can you hear that? There's a little bit of rattle in there. But this one, it's got a lot of rattle in it. We'll see how it sounds. We'll give it a little bit of a tap. Now, because that was operating well, I'm now confident that I can go from limiting mode to full current mode. And I'm just curious to see if that mechanical noise will translate into something that's going to cause us problems. Now I've got a lead in there, and that's full volume. Oh. Sometimes, I haven't cleaned out these tube sockets yet, I've got to do that, because sometimes giving them a bit of a jiggle will make noise or clear noise. All right. Even though they mechanically rattle, we can't hear anything. Got it full volume. I've got that jack still plugged in, so there's no earthing happening. Earthing of the input, I mean. All right, now let's have a look at what these values are. So this one is sitting at 27 milliamps. This one's at 32. 27, 32. We've got a bit of a difference there. I'm going to switch them around. Sometimes just putting them in a different position will draw different currents. 27, 32. Let's see how we go this way around. Nope, exactly the same. All right, 27, 32. Now, in these days of Putin pricing of tubes, I'm thinking that's not too bad. 32 divided by, oh, come on, battery's dying. 27 divided by 32, no, that way around, is 18.5% difference. Yeah, that's all right. So, now let's do a little calculation. Let's do this one. 423 by 0.032 is 13.5 watts. 6L6 is 30 watts. That's less than 50%. 45. Let's try the other one. 423, 424. Oops, 426. Make your mind up. 426 by 0.027. 11 watts. Oh, this is running way too cold. I wouldn't be surprised if we had some crossover distortion happening. I think we'll just bump up this current till we get into a happy place. This one, 419 by 0.041 divided by 30. That's about 60%, that's where I like it. And this one's 421 by 0.036. And that's 15 watts, obviously missed the decimal point. Okay, I'm going to leave it there. And I still haven't sprayed the pots, so that'll be my next job. We measured the ESR on these main filter caps. They were all way too high, triple, quadruple the maximum values. Replaced them with good quality German F&Ts. Wasn't a fault on this, but it will be. These resistors overheat, burn the board because Fender persists in mounting them hard on the board, so I've now elevated them off the board by almost 1 centimetre. We cleaned out all of those tube sockets, checked the tubes, a little bit noisy, but in these Putin days of tube pricing, I think we're just going to leave them in. They were out by, I can't remember what it was, 18%, something like that. Not too bad. We biased them. It was actually running quite cool. So I think it's going to sound a little bit sweeter right now with that new bias. It was biased at something like 45%. I think I've got it now going at something like 60. Cleaned out all of the pots, deoxidated them. Importantly, we cleaned the send and return jacks from here, especially the power amp in, the return jack. It's got some critical contacts in there that we need for good clean contact. We replaced those crappy plastic and that had a bit of an intermittent one. I think it was on number 2, I think it was quite intermittent. They just crack because of all of the mechanical movement. Well, there is now no mechanical connection between that very solid input jack and the PCB. So that should last, yeah, well, how long's a, Deluxe Reverb been around? Like 50 years, or a Tweed, something like that. So it'll last a long time now. What else did we do? Put the new handle on. Oh, I think it's about it. Let's give it a run. Now that is what a Hot Rod Deluxe is meant to sound like. Bloody awesome. You just got to set it up and it's there. If you enjoyed that video, please give me a like, subscribe, all the stuff you know to do. Drop me a comment. I answer every single comment. And I'll look forward to seeing you at the next video.